Section 3.5, Multiplying Polynomials and the FOIL method. Multiplying polynomials, monomials, binomials, and trinomials. In this section, we'll be applying everything we learned from sections 3.1 to 3.4. This section depends heavily on your ability to add, subtract, and multiply. See the examples on the next slide. Multiply 10x times 4x. Here, we're going to do 10 times 4 and do x times x, which is actually x to the first times x to the first. Please remember, when you multiply variables with the same base or same letter, you add the exponents. So 10 times 4 is 40, and x to the first times x to the first becomes x to the 1 plus 1, which is basically 2. So the answer here is 40x to the second power. 8x to the third times negative 11x to the seventh becomes 8 times negative 11. And x to the third times x to the seventh, which becomes negative 88x to the 10th. Here we're going to have to apply the distributive property, which means everything in the parentheses will be multiplied by the negative 2x to the third on the outside. So negative 2x to the third times 3x to the second, negative 2x to the third times negative x or negative 1x to the first, and negative 2x to the third times positive 2 becomes negative 6x to the fifth, positive 2x to the fourth, negative 4x to the third. The FOIL method. The FOIL method, first, outer, inner, last, which is the abbreviation for FOIL, is a method used to multiply two binomials together and basically gives a result similar to applying the distributive property. Again, this depends heavily on your ability to do the basics of math. See the next slide. FOIL. By definition, A times C is F first, plus A times D, O, the outer, plus B times C, I, the inner, plus B times D, L, the last. And this is how we FOIL. First example, multiply x plus 5 times x to the 10th. If we apply the FOIL method, then we have x times x, which is our f, plus x times positive 10, which is our o, plus 5 times x, which is our I, plus 5 times 10, which is our L, the last. Now, for those of us who are actually able to skip this step, you can go ahead and do the traditional multiplication of the terms and apply the rules of exponents and basically the rules of multiplying numbers in general. But I like to do things in steps, so therefore I wrote it out in a technical sense. But now I'm going to go back and multiply. So x times x is x to the second, plus x times 10 is 10x, plus 5 times x is 5x, plus 5 times 10 is 50. Now, when doing the FOIL method, the two intermost terms, should I say, will always be like terms. Therefore, they will always be combined together based on their signs. So both the 10x and 5x are positive, same signs, add and keep the common sign. So my final result here would be x to the second plus 15x plus 50. Another example. Let's apply the FOIL method. 4x times 3x is f, the first, plus 4x times negative 4 is the O, the outer, plus positive 5 times 3x is the I, the inner, plus positive 5 times negative 4 is the L, the last. Go back and apply the multiplication. 4x times 3x is 12x to the second. Positive 4x times negative 4 is negative 16x. Positive 5 times positive 3 is a positive 15x. And positive 5 times negative 4 is a negative 20. Once again, we do have like terms in the middle, so drop the first term down, combine the two innermost middle terms, which is going to give you negative 1x because you subtract and keep the sign of the larger number. Bring down your negative 20, and you'll be finished. Now here, it may just seem like we have a binomial and that's it. But actually, if you remember, 3x minus 2y is basically shorthand for meaning to multiply 3x minus 2y times 3x minus 2y, which turns again into the FOIL method. So we have 3x times 3x, the F, plus 3x times negative 2y, the O, the outer, plus negative 2y times 3x, the I, the inner, plus negative 2y times negative 2y, the L, the last. Apply the multiplication. 3x times 3x is 9x squared. Positive 3x times negative 2y, negative 6xy. Negative 2y times 3x is negative 6xy. And negative 2y times negative 2y is positive 4y to the second power. Bring your first term down. Remember that the middlemost terms are always going to be like terms, so therefore if you combine them together, both of them having the same signs, add and keep the common sign, that's negative 12xy, positive 4y squared. Once again, same principle. X plus 2 to the second power is shorthand for x plus 2 times x plus 2. Let's apply the FOIL method. X times x, the F, plus x times 2, the O, the outer, plus 2 times x, the I, the inner, plus 2 times 2, the L, the last. Let's apply the multiplication. X times x is x to the second, plus x times 2 is 2x, plus 2 times x is 2x, plus 2 times 2, which is 4. Bring your first term down. Combine your two middlemost terms, which is a positive 2x and a positive 2x, which is positive 4x, plus 4. Once again, x minus 5 times x minus 5, which is basically the expansion of x minus 5 to the second power. Let's apply the FOIL method. X times x, F, plus x times negative 5, the O, plus negative 5 times x, the I, the inner, plus negative 5 times negative 5, the L, the last. Let's apply the multiplication. X times x is x to the second. X times negative 5 is negative 5x. Negative 5 times x is negative 5x. And negative 5 times negative 5 is positive 25. Bring the first term down. Combine your middlemost middle terms. Negative 5x combined with negative 5x, same signs. Add and keep the common sign. Negative 10x plus 25. Now, section 3.6 is more of multiplying monomials and the FOIL method. So therefore, when you get to this section, if you choose to, it'll be doing more of what we just done in 3.5. Once again, the FOIL method. In this section, you'll be doing more of the FOIL method, which was previously introduced in 3.5. In your own time, please look through the section for even more practice of using the FOIL method. Section 3.7, dividing polynomials, subsection meaning monomials, binomials, and trinomials. Dividing a polynomial by a monomial. If a plus b is a polynomial and c is a monomial and c does not equal 0, then a plus b divided by c equals a divided by c plus b divided by c. Basically, this means you can individually divide each term at the top of the fraction by the term at the bottom of the fraction. For example, 25x to the third plus 5x to the second is being divided by 5x to the second. as I mean, basically just previously mentioned, by definition, you can separate the two separately and divide each of those two terms individually. So 25x to the third divided by 5x to the second will give you 5x eventually. And 5x to the second divided by 5x to the second is basically just 1. But if you notice here, I'm applying the quotient rule of variables that says when you're dividing variables with the same letter, you subtract their exponents. So if I simplify this, this becomes 5x, because 25 divided by 5 is 5, and 2x's from 3 leaves 1, plus 5 divided by 5 is basically 1, and of course 2x's from 2x's leaves no x's. Here's another example. We will individually divide the terms at the top by the terms at the bottom. We will apply the quotient rule of variables. And now we'll begin simplifying. 24 divided by 4 is 6, and if you take 2 from 7x's, you're left with 5x's. 12 divided by 4 is 3, and if you take 2x's from 2x, it leaves you with no x's. 4 divided by 4 is 1. However, if you take 2x's from 1x, leaves you with a negative 1x. Now we have a problem here, because if you remember from way earlier in the semester, we do not write our final answers having negative exponents. So therefore, you need to change the exponent into a positive. So therefore, write the first term down again, bring down the second term. However, you're going to create a fraction because you want to change the x to the negative first into a positive x to the first. So you create a fraction. The 1 would be at the top, and you would drop the x to the first to the bottom of it, creating a positive result. Long division. In this section, you will learn how to divide, usually using a binomial into a trinomial mainly. Sometimes you can end up dividing a binomial into a polynomial, but that will come at later in the next level of math. You're being asked to divide x plus 5 into x to the second plus 12x plus 35. X plus 5 is called the divisor. X to the second plus 12x plus 35 is called the dividend. The divisor goes on the outside. The dividend goes on the inside. Now here the x will be doing all of the division as we do this problem. Okay, so therefore that's what's going to give us our result. So we need to ask ourselves, what is x to the second divided by x? That is basically x, which is our answer. Now we take our answer and we multiply it times our complete divisor, which if you did so would give you x to the second plus 5x. You're going to take that and put that directly up under the x squared and the 12x. Keeping in mind that you are always subtracting when doing long division. So please remember to change the signs on the terms when you're lining them up. Okay, once they're lined up, combine. As you can see, the x squareds cancel out, leaving you with 12x minus 5x, which is 7x. Go ahead and bring down the plus 35. Now, ask yourself, how many times does x divide into 7x? Well, that will give you a result of 7. That is your answer. Take your answer, which and multiply it times your complete divisor. If you did so, that will give you 7x plus 35. Remember to line it up under the 7x plus 35 on the left. Keeping in mind, with long division, once again, you are changing the signs of your answer. Therefore, that becomes a negative 7x and a negative 35. Line those up. As you can see, the 7x cancels out as well as the 35, which leaves you a remainder of 0. So this divides perfectly. Whenever you do not have a remainder of 0, that means that the division leaves you with the remainder, which means that the divisor did not divide into the dividend evenly. Next example. Here we have a divisor of x minus 3 being divided into a dividend of 2x to the second minus 7x plus 3. Remember, the divisor goes on the outside. The dividend goes on the inside. So again, the x will be doing all of the division here. So therefore, on the side somewhere, ask yourself, what is 2x to the second divided by x? That is 2x. That is your answer. Take your answer, multiply it times your whole divisor. If you did so, would give you 2x to the second, negative 6x. Remember again, with long division, you are changing the signs of the result. So therefore, as you line them up, remember to change the signs. Once you line them up, combine like terms. As you can see, the 2x squareds cancel out. Negative 7x plus 6x is negative 1x. Go ahead and bring down the plus 3. Now ask yourself, well, how many times does x divide into negative 1x? That will give you a result of negative 1. That is your answer. Take your answer and multiply it times your whole divisor. And if you did so, would give you negative 1x plus 3. As you line it up, keep in mind to remember when you're doing long division, signs will change. So therefore, change the signs. Once you've lined them up, as you can see, the 1x's cancel out as well as the 3's, leaving you with the remainder of 0. One more example. Your divisor is x minus 1. Your dividend is x to the third minus 1. Now your divisor goes on the outside. Now keep in mind, pay very close attention to the dividend in this example. You notice it's missing a couple of terms. Remember, a polynomial should go in descending order from highest exponent to the lowest. Here we're missing the x squared term as well as the x term. Remember, when you have a missing term that's missing, you add a 0 in its place. Therefore, we have this as our dividend now. So we ask ourselves again to decide, what is x divided into x to the third? That is x to the second. That's our answer. Take your answer, multiply it times your whole divisor. If you did so, would give you x to the third minus 1x squared. Keep it in mind when you're doing long division, once again, to change the sign of the result. Line them up and then combine like terms. The x to the thirds cancel out. Combine the 0x squared with the 1x squared, which is 1x squared. Go ahead and bring down the 0x to the first for 0x. Off to the side, ask yourself, well, what is 1x to the second divided by x? Gives you a result of 1x. Take your answer, multiply it times your whole divisor. If you did so, gives you 1x squared minus 1x. Again, when you're doing long division, remember to change the sign of the results. Line them up, and as you can see, the 1x squares cancel out, but 0x plus 1x is 1x. Go ahead and bring down the negative 1. And then ask yourself, well, what is 1x divided by x? Which is 1. That is your answer. Take your answer, multiply it times your whole divisor, which if you did so gives you 1x minus x. Remember with long division that the signs will change of the result. So as you line them up, remember that. And as you can see, the 1x is canceled as well as the 1's, which gives you a remainder of 0.